Today we are discussing about Unit 12. Today we are discussing about Unit 12. Yes, students, today we are studying Unit 12, partial differential equations, PDE. PDE means partial differential equations. Partial differential equation. Classification, Lagrange method of solving. Classification, classification, Lagrange method of solving. Lagrange method of solving. Lagrange method of solving. Concepts. 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 X dou z by dou x. X dou z by dou x. X dou z by dou x plus y dou z by dou y. Y dou z by dou y. Dou y that equal to 2z equal to 2z. For example, this is partial differential PDE means partial differential equation. Partial differential. Formation of partial differential equation. Formation of partial PDE means partial differential equations. Partial differential equations. So by eliminating the arbitrary constant, by eliminating first one, by eliminating arbitrary constant, eliminating arbitrary constants. Arbitrary constants. By eliminating arbitrary constants. Consider the equation. Consider consider the equation. Consider the equation. F of x comma y comma z comma a comma b that equal to 0. Consider equation number 1. Here, where a comma b are arbitrary constants, let z be a regarded as function of two independent variables. Function of two independent variables. where A and B are arbitrary constant, Z be the recorded a function of two independent variables, X and Y. We have X and Y, independent variables. X and Y independent X and Y independent variables. X and Y independent variables. A comma B are constants here. B are constants. A comma B are constants. So dou F by dou X, dou F by equation 1 reduced to dou F by dou X plus P dou F by dou Y dou F by dou X dou Z that equal to 0. That equal to 0. And dou F by dou Y dou F by dou Y plus Q dou F by dou X dou F by dou X that equal to 0. Consider equation number 2. Equation number 2. So eliminating two constants A and B from 1 and 2, we obtain the equations. Eliminating A and B from 1 and 2, 1 and 2, 1 and 2, we obtain an equation of the form equation of the form equation of the form f of x comma y comma z comma z comma p comma q that equal to 0. That equal to 0. This is the first order. This is equation number 1, which is first order. First order partial differential equation. Using this concept, we'll solve one problem. That is page number 252. Page number 252. Page number 252. Form a partial differential equation by eliminating arbitrary constant. Example, easy means example sum. 12.2.1. Form the partial differential equation. Form the partial differential equation PDE by eliminating arbitrary constant from the equation by eliminating arbitrary constants from the equation arbitrary constant from the equation arbitrary constant from the equation. X square by a square, x square by a square, plus y square by b square, y square by b square equal to 2z equal to 2z. So solution, given equation, consider this is equation number 1. Differentiate 1 with respect to x first and later with respect to y. Differentiate with respect to 1 partially means with respect to 1 differential means 2x by that is 2x by a square plus with respect to x here y treat as constant, both are constant, this is 0. That equal to dou z by that equal to 2 outside dou z by dou x. Dou z by dou x. Dou z by dou x. So here too, this two get cancelled. These two will get cancelled. 1 by a square equal to 1 by a square equal to 1 by x dou z by dou x. Dou z by dou x. Equation number 2. Equation number 2. Equation number 2. Next, differentiate with respect to y partially equation number 1 partially that means first one is 0 plus 2y by b square that equal to 2 outside dou z by dou y. Dou z by dou y. That means these two and these two get cancelled. Then 1 by b square equal to 1 by b square equal to 1 by y 1 by y dou z by dou y 1 by y dou z by dou y dou z by dou y dou z by dou x. Here dou z by dou x, this implies 1 by a square equal to dou z by dou x considered as p by x. Equation number 2. Right. Similarly, here also that implies q by y that equal to 1 by b square. Equation number 3. So substituting values of 1 by a square, 1 by b square in 1, we obtain substituting substituting values of 1 by a square, comma 1 by b square in equation number 1. Then we obtain xp plus yq that equal to 2z, which is the desired partial differential equation of first order, which is desired partial differential equation of first order. First order. For desired partial differential equation of first order. Right. Hence we will. So we'll go for second concept. What is that? By eliminating arbitrary function. Next. Classification of partial differential equations. Classification of partial differential equations. Page number 258. Point 3. Classification of partial differential equation. Classification of partial differential. For example, linear equation. Linear equation. Linear equation. A first order equation equal to 0 is said to be a first order equation x comma y comma z comma p comma q that equal to 0 is said to be linear if it is given equation form is said to be linear equation. Second one, so p plus linear example for linear equation example is p plus q equal to z plus xy. Yeah, what is p here? P is dou z by dou x. Q is dou z by dou y. Next, semi-linear equation. Semi-linear equation. Semi-linear equation. Semi-linear equation. First order equation is said to be linear, semi-linear equation P and Q, and the coefficients of P comma Q are functions of X and Y of the form P of X comma Y P, X comma Y P, plus Q of X comma Y, X comma Y, X comma Y, Q, that is called R, X comma Y comma Z. This is known as semi-linear equation. Next, quasi-linear equation. Third one is quasi-linear equation. Quasi-linear equation. Quasi-linear equation. Quasi-linear equation. So, a first order linear equation f x comma y comma z p comma q equal to 0 is called quasi-linear equation if it is a linear in p and q of the form p x comma y comma z, p x comma y comma z into p plus q x comma y comma z into q equal to r x comma y comma z. Next, non-linear equation. Non-linear equation. First one is non-linear equation. Non-linear equation. Non-linear equation. Non-linear equation. Non-linear equation. The first order partial differential equation f x comma y comma z p comma q equal to 0, which does not come under the above three types, is known as the non-linear equation, which is example x square plus x square into p square plus y square into p square q square that equal to z square that equal to z are non-linear partial differential equation or non-linear partial differential equation. PDE means partial differential equation. Okay. Second order partial differential equations. So next, Lagrange method of solving partial differential equation. Lagrange method of solving partial differential equation. Page number 260. Page number 260. Page number 260. Lagrange method of solving partial differential equation of first order. Lagrange method of solving Lagrange method of solving partial differential equation of first order. First order. First order. First order. A linear partial differentiation of first order. A linear partial differentiation equation of first order. First order. Vp plus Q that equal to R. That equal to R. Equation number 1. So here PQ are functions of XYZ. Here P comma Q comma R are functions of XYZ. Functions of XYZ. And P equal to Lagrange method of solving most important compulsory for theory 10 marks question. P equal to dou Z by dou X. Dou Z by dou X. Q equal to dou Z by dou Y. Dou Z by dou Y is known as Lagrange equation. Is known as Lagrange equation. Page number 260. 260. Lagrange equation. Lagrange equation. Are obtained by eliminating arbitrary function. Obtaining by eliminating arbitrary function. Eliminating arbitrary function. Arbitrary function phi from phi of u comma v equal to 0. This can be reduced. This can be reduced. This can be reduced. Dx by p that equal to dy by q that equal to dz by r. That's right. So working procedure. Working procedure. Step 1. Step 1. solve P minus QZ to Z that equal to Z square. So step one, like that. Step one. Form the subsidiary equations. Form subsidiary DIA RY. Page number 262. Page number 262. Subsidiary equations. Subsidiary equations. Dx by d that equal to dy by q that equal to dz by r. Step two. Step two. Step two. Find any two independent solutions of the subsidiary equation. Find any independent solutions of subsidiary equations. SE means subsidiary equations. Let u equal to a. Let u equal to a and v equal to b and v equal to b. Equal to b. Where u comma v are functions of where u comma v are functions of x comma y comma z. A comma b are constants. A comma b are constants. A comma b are constants. Step 3. Step 3. Write the general solution. Write the general solution. GS means general solution. General solution. Phi of u comma v equal to 0 or u equal to phi of v equal to phi of v. So one example will solve. Example 1, page number 262. Example 12.4.1. Solve p minus q z equal to z square plus x plus y whole square. So solution. Write the subsidiary equations. The form given equation can be written as Ez minus Qz that equal to Z square plus x plus y whole square. X plus y whole square. So then the subsidiary equations are subsidiary equations are subsidiary equations are dx by z most important dy by minus z that equal to dz by z square plus x plus y whole square x plus y whole square x plus y whole square. Considering the first two ratios, we get, considering the two ratios, is that dx by z that equal to dy by z minus z. So z get cancelled. We'll get dx equal to minus dy. Dx equal to minus dy. So by taking integration both sides, we obtain x equal to minus y plus c1. This can be written as x plus y equal to c1. So equation number, consider equation number 1. Equation number 1. Considering the first and third ratios using 1. Considering first and considering first and third ratios. First and third ratios. What is the first ratio? dx by z and using 1. Using equation number 1. That equal to dz by z square plus c1 square Z square plus C1 square is nothing but C1 only. Okay. Then, so integration both sides. Dx equal to shuffling. Shuffling we need to do. That is mean nothing but variable separable method. Z dz whole divided by Z square plus C1 square. So we have a formula from integration. F dash x by f of x dx equal to log mod f of x plus c of x plus c. So integration both sides. So multiply and divide by 2. That means x equal to 1 by 2 log mod z square plus c1 square plus c2. C1 equal to c2. Here equation number 2. So 1 and 2 are the solution. So this can be written as solution, general solution, GS. General solution GS equal to x plus y and comma x minus 1 by 2 log mod z square plus c1 square plus c1 square. C1 square. Next. Okay. We'll solve one more example. That is 263, page number 263. Solve p plus 3q that equal to 5z plus tan y minus 3x. Most important for long answer type question. So Lagrange's subsidiary equations solution. Lagrange's subsidiary equations. Lagrange's subsidiary equations. Lagrange's subsidiary equations. Dx by 1 that equal to dy by 3 that equal to dz by phi z plus tan y minus 3x. We wrote subsidiary equations. Then taking first two ratios, taking first two ratios, taking first two ratios, first two ratios. First two ratios that equal to integration dx equal to integration 1 by 3 will take outside dy that equal to x equal to 1 by 3 y plus c1 that becomes y minus 3x equal to c1 equation number 1. Taking first and last ratio, using equation number 1. What is the first ratio? dx by 1. What is the last ratio? dz by phi z plus tan c1. So integrating both sides. Integration both sides. X equal to 1 by 5 outside. d by dx 1 by x is log mod x. Log mod phi z plus tan c1. Sorry, z only. 5 would come on c1 by 5. c1 by 5. Total constant plus c2. So equation number 2. Here 1 and 2 are the solutions. 1, 2 are solutions. This can be written in the form general of y minus 3x comma 1 by 5 log mod z plus tan c1 by 5. Hence the solution. Right. Next. One more sum we'll do. One more sum. That is page number 262. Example. Example 12.4.4. Solve x square minus yz, x square minus yz into p plus y square minus zx, y square minus zx, q z square minus xy. Solution. Subsidiary equations of the given equation. Subsidiary equations of subsidiary equations of given equation. Dx by x square minus yz, x square minus yz, that equal to dy by y square minus zx, y square minus zx, y square minus zx, that equal to dz by z square minus xy, z square minus xy, right? Here dx minus dy, then dx minus dy minus dy, dx minus dy, x minus y, x minus y into x plus y plus z, x plus y plus z. That equal to dy minus dz, dy minus dz, y minus z, y minus z into x plus y plus z. That equal to dz minus dx, dz minus dx minus dx, z minus x into x plus y plus z, x plus y plus z. The first and second ratios, first and second ratios, first and second ratios, first and second ratios is expected answer dx minus dy, dx minus dy whole divided by x minus y, that equal to dy minus dz, that equal to y minus z, because here x plus y plus z, denominators get cancelled. So integration both sides. Integration both sides. What will get log x minus y? Log x minus y equal to log y minus z plus log c1 plus log c1. That implies by logarithm properties and use log x minus y whole divided by y minus z, that equal to log c1. Log c1. So here log get cancelled. Then x minus y whole divided by y minus z, that equal to c1. So similarly, considering the second and third ratios, simplifying, considering second and third ratio, second and third ratio, second and third ratio, we get z minus x by z minus x by y minus z. C1 is the C1. Here, the general solution can be written as the general solution can be written as can be written as can be written as x minus y whole divided by y minus z, comma C2, this is z minus x whole divided by y minus z, that equal to C2. Hence, okay, these are the here page number 263. Example 12 point, example 12.4.4. Do it as homework for 10 marks theory question, right? Okay. Students, you have any doubts? Please ask me. Okay. Don't have any doubts, I think. Okay, thank you. I'm leaving. Wish you best of luck in theory examination.
Three itself. It would three itself.